Hello! Today I want to talk to you about one of my favorite little critters, the Kentucky cave shrimp. This is a shrimp that is native not only to just Kentucky, but just our tiny region of Kentucky, just in an area of a few hundred square miles. It's crazy to think that something like this exists just right here at home. This little tiny little ghost of a crustacean. So, the Kentucky cave shrimp was discovered by H.P. Hay. He discovered them during a deep cave expedition, my apologies, into Mammoth Cave. He discovered them alongside Roaring River, this rather poorly named stream that's around 20 feet across and on average around a foot deep. There are small pockets along this stream that have been carved out. That's where these shrimp seemed to dwell. He sent 3 of them to the Smithsonian for catalogization. Not sure if there's a better word for that. Registration? And also recorded his findings and submitted them to the appropriate societies and sources. Their name, Palaemonius gentari. Gentari is actually named after the biologist that was in charge of Mammoth Cave National Park. This biologist was really, really involved with all of the creatures down there, and H.P. Way found that really inspiring, and now he has a shrimp named after him. So, for a while, up until the 1970s, we thought these guys had gone extinct sometime around the 30s. We stopped seeing them. We stopped seeing dead ones, we stopped seeing living ones. They disappeared from Mammoth Cave altogether. We'll get into the reasons behind that later. But since then, they have reappeared and they've become a lot more common. Not common to the point where they're, underfoot, but common to the point where you might see one if you're very lucky and you go down into the deep enough caverns. So, habitat and ecology. The Kentucky cave shrimp are found in only one place on Earth, the deep caverns of Mammoth Cave. And that's something that's very important to understand as far as a preservation aspect goes. Because if something happens to Mammoth Cave, that's it. They're gone. There's no other secondary habitat, there's no other forest they can live in. It's just that is their habitat. That is Mammoth Cave. That's it. The reasoning behind this is you can think of cave systems as similar to island isolation. On islands, it's very hard for most creatures to leave said island. And in the same way, creatures tend to get trapped in the caves. That causes very little genetic drift, which means that it's not uncommon to find large cave systems like Mammoth Cave that have species that are entirely unique to just that cave system and nowhere else in the world. So, because they live in their little cave system, they're very well adapted to it. They have tiny, tiny little eye stalks that are basically gone. They are completely blind and cannot see anything, but they make up for that with their very sensitive antenna and sense of smell and taste. They can feel minute vibrations in the water, which allow them to sense their predators coming and scamper off if need be, as well as smell little bits of matter that they would like to eat. Little teeny tiny creatures, crustaceans, and tiny little decapods, things along those lines. Planktons, bits of leaves that wash in from the surface, and they graze along that on the bottom. They're also small, very small, around a little under an inch on average. Around 20 to 25 millimeters is what you would typically see, but they have been seen bigger, but it is very rare. They are reliant on their ecosystem. If they were to leave their ecosystem and go to live somewhere else, they would probably not survive very long. See, it's all well and good to have such specialized stuff to sense vibrations and the like when your predators are also blind, like the blind cave fish and the blind crayfish. But if this little guy was out in the open, where predators could see it and it could not see them, it would likely not do very well. So, this is just from what we can observe as their habitat. And because of their habitat is so cut off, we can't be entirely certain that this is the main area in which they live. There could be smaller caverns that we can't get into where there are much more complete ecosystems of these shrimp. But for right now, we're considering the pools and deep caverns where they live that we have access to as being exemplary of their habitat. Okay, so their ecosystem works in a pretty nifty way. So as I've said several times, and as is fairly obvious, there is no light in a cave, at least not in most caves. And as your middle school science teacher taught you, light is essential for survival of anything. Light is the main source of energy that we as humans and every other animal eventually absorb through our food. So, believe it or not, the main basis of the shrimp's ecosystem is still light, just not light that enters the cave. So, water comes and washes up bits of twigs, bits of bacteria, little tiny bits of decaying matter, leaves, sticks, little blobs of old decaying wood, tiny, tiny little things that can be picked up by the streams and rivers here. And these nearly microscopic particles are washed down into pools and basins that then empty down into the Mammoth Cave system. This stuff that's inedible collects on the bottom as a silt, and the stuff that is edible remains in the water column, where creatures like the shrimp eat them. Now, shrimp eat them, the little bits of detritus, and then things like the cave crawdads and the blind cavefish will eat the shrimp. So you have a nice little self-contained ecosystem here. Not very highly biodiverse, at least not that we've seen so far, or cataloged, but it is functioning. All self-contained, without without much exterior involvement. Only thing coming in from the outside is detritus, and that supports all life in the Mammoth Cave systems. Life of a shrimp. So, as I've said numerous times, their habitat is very, very hard to get to, and most of it hasn't even been explored. They live in deep, deep caverns, and many of them live in caverns that have no openings that we as humans can pass through. Meaning we only have a small sample size of the ones that are in the higher up caverns and in the pools where they get trapped during flood times. So we have never observed them mate, but we have observed many females with eggs. They tend to, it's not confirmed, but it's a general observation, perhaps it's coincidental, but females tend to produce more eggs during times of flooding in the surface. And that's because when it floods up here on the surface, you have a lot more stuff that's getting picked up into the water column and then brought down to the shrimp. And so the shrimp and their children can then eat it. Of course, you'd want to have children around a time when there's enough food to feed said children. So we have never really seen newborn cave fry, which is a shame because that would help us a lot for understanding their life cycle. But as far as we know, they're the same as other freshwater shrimp species, as far as how their larvae develop. But that is completely unconfirmed. It is just an assumption that has yet to be challenged by any data because we have very little data on it. Another thing that makes it frustrating is they do not hatch their clutches all at once. Females don't. Instead, they keep their eggs on their body. You can see right here you have a female that has her eggs, and they hatch in small bursts over the course of a little while. That makes it really hard to estimate their total population. because we can't just look at a female and go, okay, so a female has this many eggs and they hatch at this time, and this is how many babies survive and all of this, because they stagger their hatchings. Cave shrimp, I was surprised to learn this, they grow pretty slowly for shrimp, but they live for 10 to 15 years. So there's cave shrimp. These little tiny blind crustaceans live as long as your typical cat or dog. And I think that's pretty remarkable because we don't really consider little tiny arthropods, little tiny crustaceans, as being something that's that long lived. But I guess if you grow slow enough, you can live for quite a while. Threats and preservation. So, Kentucky cave shrimp were thought extinct for a long time, like I said earlier, only being rediscovered in the 1970s when we found a dead one that had washed up on the side of a cavern. But now that they are rediscovered as being alive, we have successfully gone through the process of getting them registered as an endangered species. So them and the caverns where we know they live are now protected. You can't harvest them, you can't kill them, you can't build anything in the caverns. Not sure why you would want to. But you can't really do anything that's likely to disrupt their habitat. So that's the question. Begs the question, what caused them to decline so much in the first place? Well, we don't entirely know, but water quality plays a large part in it. At least we have correlation that it does. When water quality gets worse, shrimp population gets worse. When water quality gets better, shrimp population gets better. That's pretty good evidence on all of its own. But because we know so little about these shrimp, we can't 100% say that that is what is causing it. But for right now, let's assume that it is for the sake of this argument. So, industrial waste. This is a big problem with a lot of water-dwelling creatures. Industrial waste like car oil. Believe it or not, cars leak a lot of oil onto highways that then gets washed into streams and gutters. Fertilizers, pesticides, things that we wouldn't really consider being that dangerous get washed off of lawns and out of farm fields and end up in our waterways. Now, you do have individual responsibility for this. We have to make sure that us as individuals are not dumping chemicals and things like that. But the main problem is companies dumping things. See, companies do not like to transport their waste. It's very expensive and very annoying. So what they do instead is they dump it in the nearest waterway. This has gone a lot better because recently, well, within the last 50 years recently, America, at least, has passed a act called the Clean Air and Water Act. And this act basically makes it so it limits, but does not stop companies from dumping industrial waste. And it's very, very shocking to me that even though we have less dumping today, companies are allowed to dump several tons of waste per year into public waterways. So right now, since we have put those protections in place, we have around 5,000 to 10,000 shrimp. That may seem like a lot of shrimp, but remember, these are shrimp. They're very small. Normal shrimp populations are in the trillions. So still a very, very endangered species. But their population is on an upward trend for right now, so that's something good we can look forward to. Wastewater, there's a misconception that when you dump waste into a stream or to a river, it just goes away, just washes away, it dissolves, it becomes harmless. But it doesn't. It ends up in places like Mammoth Cave. It ends up in places like your drinking water, your water that you shower with, the water that's in the streams and lakes and ponds that you fish from and eat the fish from. It may not be as obvious, its effect on humans, but these little shrimp are a great way of seeing. They're kind of like a canary in a coal mine, if you will. They show that the detriments of water quality have reached a point where it affects the shrimp, and it's only a small step from there where detriments in water quality can severely affect people. So it's our responsibility to protect our waterways, not only for the sake of the animals that live there, but for also the sake of the people that rely on it, us. Because waste doesn't go away. It ends up in ecosystems, and it ends up in you. All right, that was the presentation. I wrote it. I used information from the U.S. Department of Fish and Wildlife and the National Park Service. And thank you for listening. I hope this has been informative.